stuff for the Unit 2. Not the kind of last day, but the last day of new stuff. And when I do the last day of new stuff, I drink, no, it's like 10:40. I'm not drinking coffee. Maybe I should be. Apparently water's deadly to me. But if I drink water, it's got to be in a Dunkin' Donuts cup, which is not a great commercial for Dunkin' Donuts. Just I just about choked to death. Sorry, kids. My name is Mr. Krause. Just call me Mr. K. Mr. Key. Ooh, some seriously good penmanship there. All right, kids. Solving double radicals. Solving radical equations aren't bad. Solving double radicals can be a little bit tricky. So, this is key. One radical per side. Square both sides. Algebra. Get the radical alone. And then this stuff from here down is what we did on day, I don't know what I'm about to write, day 6. So from here down is day 6. This part here is day 7. And that's the tricky part. So let's just see how it works. Let me get a little bit bigger here so you can see it. So we're going to look on this problem right here. So you'll notice that we have this thing in my way. You'll notice that we have two radicals. We have this radical and this radical. So what we want to do is, just like the directions say, we want to get one radical per side. My goodness, I'm a wreck today. See that? Maybe I need to be drinking more coffee. One radical per side. We want to get one radical basically all by itself, and then all the other crap on the other side. So that's what we have. So one radical per side. And it has to be one radical by itself. Then what we're going to do is square it. Now here's where it gets a little funky. We're going to square this. We're going to square this. Now squaring this just means you're going to write it twice. This first one's not too bad. Okay. So when we square the left side, the square and the square root cancel, and I end up with just x minus 21 equals. Now this one we have to do some double distributing. So we're going to do square root of x times square root of x, which is just x. Square root of x times minus 3 is minus 3 square roots of x. I'm going to go slow. And then minus 3 square roots of x. And then plus 9. All right. Now, you'll notice we still have a radical. That's the problem. We still have a radical. So what we have to do is clean it up. Little algebra, clean it up, and then isolate the radical again. So that's what we're going to do right now. So on the left side, I'm just going to leave it as x minus 21. And I'm going to write this as x plus 9 minus, and I'm going to combine these two, minus 6 square roots of x. All right, so I want to isolate. What I need to do is I need to isolate this radical all by itself. So that's what we're going to do now. So we're going to subtract the x over. And those go, and those go. That's nice. We're going to subtract the 9 over. And I get negative 30 equals negative 6 square roots of x. Well, we still need to isolate that radical. So now I'm going to divide by negative 6. Divide by negative 6. And I get the square root of x equals 5. All right, we're in good shape. Now that you have a radical all by itself, now we square both sides. And I get x equals 25. So in this case, we only have one solution. Lots of times we'll have more than one solution. Now let me come up here real quick and just check it. The square root of 25 minus 21, that's really just the square root of 4, which is just 2. So this side is 2. This side is the square root of 25 minus 3, which is really 5 minus 3, which is equal to 2. Check. We're good. So we're good. We checked it. Check for extraneous solutions. All right, let's keep going. All right. Now you'll notice in this case we have both radicals on the left. That's a problem. Can't do it. If you tried to even do something with that right now and square both sides, you would have a crazy problem. And we always get a kid that does this. Let's square this. Let's square this. Let's square this. X minus 3 plus x plus 5 equals 16. You know what we like to call that? I think there's a poop emoji for it, like a little poop emoji. I'm not a drawer. It's a little stinky, stink. That's a poop emoji. Yuck. Can't have poop emojis. Doesn't work that way. It's not like that. It's not even close to being accurate. Can't do it, right? Because what I'd have to do is square this whole side, write it twice, and dump. Oh, man, you'd end up in a big world of hurt. So we won't want to do this. So we're going to just slide this one over here. by subtracting it over. So I get the square root of x minus 3 equals 4 minus the square root of x plus 5. Now notice that we just subtracted it over. All right, now we're going to square both sides. A little black and red for Hilton. Now I know squaring this side just means write it twice, so I'm just going to do that now. I think that makes a lot more sense. There's no sense in writing squared and then writing it twice anyway. You might as well just write it twice. Left side's easy. It's just x plus, oops, excuse me. Of course, it's only easy if you read it correctly. Minus 3 equals, all right, now we got some work to do. That's 16 minus, now I'm going to do this one together. Minus 4 and minus 4 is minus 8 square roots of x plus 5. And then this negative times this negative is positive. And when you multiply x plus 5 times x plus 5, you get x plus 5. All right, let's see what we got. I don't really need these parentheses then. I do need that x. I'm going to clean up the left side, or the right side. 16. Nope, not 16. We've got 16 and 5. That's 21. So 21 plus x minus 8 square roots of x plus 5. All right. Now we have a new radical that we have to isolate. So the first step really is designed to get rid of one of the radicals. Then you just got to kind of do it again and get rid of the second radical. The math actually is not that difficult. You just got to pay attention to detail. So we're going to subtract this x over. Gone. That doesn't always happen. We're going to subtract this 21 over. Be careful with your math here. This is negative 24 equals negative 8 square roots of x plus 5. We're going to divide by negative 8. And I get 3 equals the square root of x plus 5. All right. Now we're going to square both sides. We got the thing alone. Now we square both sides. And I get 9 equals x plus 5. I subtract 4 over and I get x, or excuse me, I subtract 5 over and I get x equals 4. And don't forget, I want your answers looking like, not like that. That's terrible. I want your answers when you're done to kind of go 4. Make it look professional. I should have done that up here. I don't know why I didn't. What's the answer up here? 25? So my answer up here is 25. Make it look professional. Okay, we do need to check this. So I'm going to check this off to the side here. Let me rewrite it real quick. The square root of x minus 3 plus the square root of x plus 5. I'm hoping that equals 4. All right, so 4 was my number, so I'm going to plug a 4 in for x, and hopefully I get 4 out. So the square root of 4 minus 3 plus the square root of 4 plus 5 equals 4. Actually, does it equal 4? I don't know. That's what we're checking. This is the square root of 1 plus the square root of 9. Does that equal 4? And yes, 1 plus 3 equals 4. Checks. Got it. Nailed it. All right, this one's a little bit different. If you look at the answer, if you look at this question the way it stands right now, if you're really good at math, you realize that the answer to this question is going to be no solution. Now, pause the video if you want. Take a look at it. Tell me if you can figure out why in the world, if you're really good at math, you know that the answer is going to be nothing. It can't work. All right, I'm assuming you're back now. So if you're back now, I'm going to tell you why. Why? Because how do I add two things together and get 0? That's not possible. You can't add two things together to get 0. Doesn't even make any sense. So the solution has to be empty set. This would be like a really cool SAT question where you went through all this crazy work and realized the answer was 0 or was an empty set, right? Because if you inspected at the beginning, it could be an empty set. Well, let's see what happens. We're going to slide this over. It becomes negative. So square root of 2x minus 5 equals negative square root of x plus 6. All right, we're going to square both sides. This is just 2x minus 5 equals, now squaring this side Squaring a negative is positive, and then you square that thing, it's just x plus 6. So let's see, subtract x. So I get x minus 5 equals 6. Wait a second, we're getting an answer here. X equals 11. Maybe I was wrong. Maybe you can have an answer to this question. Let's see. The square root of 2 times 11 minus 5 plus the square root of 11 plus 6. That definitely equals 0, right? Wait. This is the square root of, let's see, 22 minus 5 is 17. So this is the square root of 17 plus the square root of 17 equals 0. Well, the square root of 17 plus the square root of 17 is not 0. It's definitely not 0. So just because you came up with an answer doesn't mean there's actually a solution to the problem. This is the answer, empty set. All right, that's a little weird. All right, last one. Now, oh wait, we got, I think, 3 more. 3 more. All right, they're going to get a little more interesting now. All right, so since we already have the radical by itself, I'm just going to square this. Now this one I got to write twice, so I'm actually going to rewrite this just because of the way it's written. These problems are very difficult to write, so they come out right. They're a pain in the neck. Actually, are these the ones? I think these are the hard ones. When I multiply these two together, I just get x plus 2. There's 1 square root of x plus 2. There's another 1 square root of x plus 2, so that's plus 2 square roots of x plus 2. And then 1 times 1 is 1. Equals 3 minus x. Okay, we're going to have some work to do on this one. On the left side, I have x plus 3 plus 2 square roots of x plus 2 equals 3 minus x. Subtract x, subtract x, subtract 3, subtract 3. Well, these are going to go, these are going to go, these are going to go. So I end up with 2 square roots of x plus 2 equals negative 2x. All right. We still don't have that radical by itself, so I'm going to divide by 2 and divide by 2. And I get the square root of x plus 2 equals negative x. All right, now I've isolated the radical. I'm going to square both sides. So what I end up with is x plus 2 equals x squared. Remember, negative times negative is positive. Squared, anytime you have a squared, we now have a quadratic to solve. So we're going to bring everything to the right side. We get 0 equals x squared minus x minus 2. Now we factor. Hopefully that factoring is pretty easy for you. Shouldn't be overly challenging. It's going to be minus 2 and plus 1, right? They multiply to negative 2 and add up to negative 1. So my two answers appear to be 2 and x equals negative 1. I'm going to tell you that the negative, not always, be careful, but the negative oftentimes is the problem. The positive is usually okay. Usually, not always. So let's go back up to the original. So the two answers we came up with were 2 and negative 1, right? So we came up with x equals 2 and x equals negative 1. So I want to check these. 2 plus 2 plus 1, does that equal the square root of 3 minus x? Let's see. Square root of 2 plus, let's see, 2 plus 2 is 4. The square root of 2 is, the square root of 4 is 2. So this becomes the square root of 4, which is 2. So 2 plus 1, which is 3. And then, oh, I should have put a 2 in here, right? So this is 3 minus 2, which is 1. So this is the square root of 1, which is 1. Those don't work. Looks like 2 is not a solution. That's weird. Let's try the negative 1 then. Maybe the negative 1 is a solution. Let's see it. Usually it's the negative that's the problem, but like I said, it's not always the case. So negative 1 plus 2 plus 1. Does that equal the square root of 3 minus, careful here, negative 1? See how you got a double negative? Maybe that's why we're okay. Let's see. Negative 1 plus 2 is 1. So this is really the square root of 1 plus 1, which is really 1 plus 1, which is 2. Over here, we've got the square root of, let's see, that's 3 plus 1, which is 4, which is 2. There is a perfect example where the negative worked and the positive did not. So don't be like some of my kids in the past where I say usually it's the negatives you got to be aware of and just cross off the negatives. Like, I checked it, Mr. Krause. I definitely checked it. Don't be that person. All right, what do we got? 1 left, 2 left, 2 left. All right, we got the isolated radical. So I'm going to square both sides. So write this twice. Oops. Square root of 3x minus 8 plus 1. Square root of 3x minus 8 plus 1 equals the square root of x plus 5 squirt. All right, let's see what we got. Multiply these two together. I get 3x minus 8. One of these and one of these is 2 of these, so plus 2 square roots of 3x minus 8 plus 1 equals x plus 5. All right, it's about to get weird, I think. So this is 3x minus 7 plus 2 square roots of 3x minus 8. I'm just cleaning stuff up a little. Equals x minus 5. I just put these two together. So now I'm going to subtract 3x. Subtract 3x. And I'm going to add 7. Add 7. So I get 2 square roots of 3x minus 8 equals negative 2x plus 12. All right, that turns out to be okay. Going to divide by 2. And I get the square root of 3x minus 8 equals negative x plus 6. All right, now we've got the isolated radical. So now we go to town again. We do the same thing, square both sides. You can see there's lots of signs issue that you always, that's just algebra 2. Algebra 2 has so many negative issues. Not like being negative, just like so many negatives. And you just got to be really, 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 really careful with them. All right? All right, get rid of that crap. Negative x plus 6. Hopefully this works out nicely. So on the left side, we get 3x minus 8 equals x squared, because negative x times negative x is positive x squared. This is minus 6x and minus 6x. That's minus 12x. And then plus 36. All right, we have a quadratic to solve, which means everything has to come to the right, because you always want your x squared to be positive when you're working with these. So minus 3x plus 8 plus 8. So I get x squared minus 15x plus 44, and it equals 0. Well, I'm out of room here, so let me write that up here. Hopefully this factors. I think it does if I look at it. Oh my goodness, what happened? Is it minus 15x? What happened? Come on, stop being a jerk. Stop being a jerk. Yeah, minus 15x. So 0 equals x squared minus 15x plus 44. And how about minus 4 and minus 11? 4 times 11 is 44. 4 and 11 is 15. So I get two answers. X equals 4 and x equals 11. Whenever you get two answers, there's a pretty good chance, especially if this is a bonus, that one of them will be extraneous. In other words, one of them's a bogus answer. It ain't going to work. Let me copy over that problem real quick. Forgot what the problem was. So 3x minus 8. I should have put that check up higher. The square root of 3x minus 8. How old am I that I don't remember the rest of that? Plus 1, and then the square root of x plus 5. plus 1 equals the square root of x plus 5. All right, we're going to check them both. So we're going to plug the 4 in for the x, see if it works. So 3 times 4, I'm going to try to speed things up a little bit here. That's 12. So that's 12 minus 8 plus 1. Does that equal the square root of 9? Which is, so the right side is just 3. 12 minus 8 is 4. Square root of 4 is 2. So this is 2 plus 1. So check. And then the last one I'm going to check is at 11. So we're going to do the square root. I'll write all this out. 3 times 11 because it's a little weirder. Minus 8 plus 1. Does that equal the square root of 11 plus 5? Well, 33 minus 8 is the square root of 25 plus 1. Does that equal the square root of 16? Let's see, the square root of 25 is 5. 5 plus 1 does not equal 4. So the only solution, the 11 did not work. The only solution is the 4. And I like to do that. I also like to come up here and cross off the bogus answer. All right, we got one left, children, and then we're done with this. Oops, there it is. Oh, man, I went way down into this one. All right, so let me get rid of all this stuff again. You can rewind the video to see what I did there. All right, let's square both sides. Squared. And this one I'm going to write twice. So on the right side, or on the left side, I get 3x because the square and the square root just cancel each other out. Equals 9. Positive 3 of those things and positive 3 of those things is positive 6 square roots of x minus 3 plus x minus 3. All right, everything goes to the left side, so let's just do that. Subtract x, so I get 2x. This is 9 and minus 3, so that's going to be a problem. 9 minus 3 is 6, so that's positive 6 on the right, so we're going to subtract 6 over. So I get minus 6 equals 6 square roots of x minus 3. All right, so here's where I'm going to show you something that you can do in order to avoid having to work with fractions. So don't write this down. Normally I would come in here and I would divide by 6, divide by 6, divide by 6. But that's a problem, right? That's 1/3. And then what am I going to do? Start factoring and double distributing with 1/3? That's a pain in the neck. So we're not going to do that. There's another way around that which you can do. You just got to be really careful with it. What we're going to do is we're going to square this side and we're going to square this whole side. And you can do that. That's okay. It's totally legal. It's a way to avoid fractions when you have them. All right, so this one is 2x minus 6. You'll see how it works. 2x minus 6 equals 6 square roots of x minus 3 squared. So on this side, I get 4x squared minus 12x. Minus 12x is minus 24x plus 36 equals, now, what you have to do is that squared has to go here and here. So if I square the 6, I get 36 times x minus 3. Because this thing, the square and the square root just cancel each other out. This is a tough problem right here. 4x squared minus 24x plus 36 equals 36x minus 108. Right? 36 times 3 is 108. Everybody knows that. Bring everything to the right side or left side, 4x squared. Subtract 36x. Let's see, what is that? 10, carry to 1, 60? Is that 60? Yep. Minus 60x. Oh, plus 108. What is that, 144? I believe we can take out a 4 here. So we're left with x squared minus 15x plus 36 equals 0. X minus 3, x minus 12. Sorry, I'm moving pretty quickly. This problem's really hard. Those are my two answers. My two answers are going to be x equals 3 and x equals 12. I don't know if one, both, or none of them work, and you have to check that. So we're going to write that problem over here, the square root of 3x, does that equal 3 plus the square root of x minus 3? So we've got 3 and 12. So let's try plugging in x equals 3. So the square root of 3 times 3, that's the square root of 9, which is just 3. Does that equal 3 plus the square root of 3 minus 3? Well, the square root of 3 minus 3, that's 0. So that's just equal to 3. So it looks like 3 works. Now we're going to try x equals 12. Square root of 3 times 12. That is the square root of 36, which is just 6. Does that equal 3 plus the square root of 12 minus 3? 12 minus 3 is 9. The square root of 9 is 3, so that ends up being 3 plus 3, so that checks. So in fact, they both work. That doesn't often happen, but this time it does. We have two solutions, 3 and 12. Now, one last thing I want to share with you, if you ever want to know how to get the answers or another way to check them, is to do it like this. What we could do is just graph the left side and graph the right side. So let me do that real quick. I know this is going to be a little weird for you, but you could just graph them just to check it. So go into graph mode. So I'm going to graph the square root of 3x. And I get weird stuff. Right there it is. Then I'm going to hit tab, and then I'm going to hit 3 plus the square root of x minus 3. Bam. Now, it looks like they might hit each other here, and it looks like they might hit each other here. So what we're going to do is we're going to go to Menu, Analyze Graph, Intersection. Click, click. Look at that, point of intersection. It even says point of intersection right there, 3, 3. So one of your X answers is 3. Let's do it again. Menu, Analyze Graph, Intersection. Click, click, click. And if you move this stuff, you'll see that the other answer is 12. And we can see that those are 2 points of intersection. That's another way to check it graphically as opposed to algebraically. I don't think your teacher really matters which way you do it, but, just another option for you. Catch you on the flip side, kids. Bye.